Let's finish out chapter 7. We've talked about secants and we've talked about tangents. So we're going to kind of combine those in this lesson to talk about some special segments. Our first theorem talks about if two chords intersect, then the products of the lengths of the chords are equal. So let's take chord AE. So we have a segment here of AE, and product means multiply, and ED. Then that is going to be equal to the product of our other segment over here, BC. So its segment is BE and EC because they all intersect at that middle point, E. Okay, our next one, this is also referred to as secant segments. It sort of has the same thing here. We have two secants, but notice where they meet is on the outside of the circle. So here's my first segment here. And it says that if BC times AC, if they intersect at point A, which they do, then the product of those two little segments, segment DE and AD, then those are also equal. Okay? Now for my last theorem here, I'm going to use 3 colors because I have a tangent and a secant. I've got this tangent right here, and it says if I square the length of it, then it is equal to the product of LM times JM times this little piece here. So kind of similar to our last couple, except instead of doing JK times the other half, since it's a tangent, it's JK times JK, which is where they come up with JK squared. So all of these are pretty much saying the same thing, is that if you have a secant or a tangent, the product of those are equal. So we're going to use that to find x in our first example. We're going to use our first theorem that we talked about. We said that if they intersect in a circle, and they do, then the product of these two pieces are equal. So x times 8, or 8x, is equal to the product of 9 times 12. So I can go ahead and figure that out. 9 times 12 is 108. And then I need to solve for x. So divide by 8. And yes, you will get a decimal. 13.5. Alright, let's try letter B. Okay, same sort of thing, but now I have a little bit more complicated. Now I have x's on all of my segments. So we may have to remember algebra. X plus 4 times x plus 2, this secant right here, is equal to this secant PR, x times x plus 10. Okay, you do need to FOIL this. Remember firsters, outers, inners, lasters, and all of that. So x squared plus 6x plus 8 is equal to x squared plus 10x. If I minus x squared, what happens? They both cancel out. Okay, so let's take our 6x to the other side with the 10x. So I get 8 is equal to 2x. What is x? X is 4. I think your book likes to make x 4 because x is 4 a lot. Okay, in example 2, that orange blob is our organism. And 2.5 millimeters is this little piece right here. Okay. I'm going to give this circle some letters just so we can easily reference things. Okay. Okay. I know that the this part is 2.5, and I know that this circle has a diameter of 2. So if this is 0.25, CB, how long is CB? CB is 1.75. Okay. And I know that I have something that we talked about last couple chapters ago, where this is a chord, so it makes BD and AE equal. So I'm going to write that over here. BD equals AE. Or not AE, BE. Sorry. Okay. Since I know that, how can I find the length of the organism? Remember we talked about making a triangle here? Okay, if this is 0.25, this is 1. If I pull this out, then I can have a triangle. That's one way to do it. Or I can use my product of secants that I just learned about. And that says that the pieces of the secants, the product is equal. So if this, I don't know how long it is. If it's x, then I know that x times x, x and x, is equal to the product of this little piece, 0.25, times this piece, BC, which is 1.75. That's a whole lot easier than doing the whole Pythagorean theorem. So I get x squared is equal to 0.4375. And then you have to square root that with your calculator. And you'll see that x is about, it says round to the nearest hundredth. So 0.66 millimeters. That's about how long my little organism is. Okay, example 3. Here we have 2 more secants. And so, same thing, except I need to know how long EI is. EI is 8 plus x. I need to know how long EG is. It's 34. Because when they intersect outside the circle, then I have to take the whole length. So to find x, it's this piece right here, GF, which is 24, times the total length, 34, equals this little piece, IH, which is x, the secant inside the circle, times the entire length. And let's go ahead and simplify that. 8/16 equals 8x plus x squared. Okay, since our x squareds can't cancel because I only have 1, let's move everything to the right side, set it equal to 0, so that we can see if we can factor. So we get x squared plus 8x minus 8/16 equals 0. Okay. Can I factor this? Nope. So I have to use the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac. Can't write as fast as I think. All over 2a. Use your calculator. Go ahead and evaluate that. Make sure you're very careful as to what you put parentheses around. And you will see this comes out to be about 24.84. That is what x is. Okay? Last example, number 4. LM is tangent to the circle. Find x. So this is our last theorem. Remember we said that the tangent line, if we square it, it's going to equal the sum of this secant part, jk, which jk is x plus 2, times the whole length. How long is JL? Well, x plus x is 2x plus 2. That's how long the whole thing is. So times 2x plus 2. Okay, let's simplify this and FOIL the right side. 2x squared plus 6x plus 4. And, of course, quadratic, so set it equal to 0. And since we all have even terms here, 2, 6, and negative 140, let's divide by 2 to get rid of that coefficient because it's a lot easier to factor when it is not like that. Okay, can I factor this? I sure can. I can factor this into x plus 10 and x minus 7. So it says to find x. So if I set each one of these equal to 0, I find I have two answers, negative 10 and 7. Now, you have to use common sense. Does it make sense to have a length of negative 10? No, it does not. So, my only logical answer is 7. X equals 7.